Okay, so let me read this to you guys. For problem number 5, it says that a 250 Newton force is applied at a 37-degree angle to the surface of the end of a square bar. The surface is 4 centimeters on a side. What is the compression stress and the shear stress? Okay. So the compression stress. So let's draw the picture and we'll go from there. This is problem number 5, and we have like this square bar. Whoops, that's not quite right. This is better. Like we have like this square bar. Okay. And the compression stress, if you guys recall from your notes, your compression stress is equal to the force times the cross-sectional area that the force is being applied. And remember, that's if it's perpendicular. If it's not perpendicular, then it's the force sine of the angle. And in this case, the angle of the force applied is 37 degrees over the cross-sectional area. Now, they said it's a square, and the side length of the square was 4 centimeters. So this was 4 centimeters, and this is 4 centimeters. But remember, 4 centimeters is like 0.04 meters, right? And so the area of that is really just like 0.04 meters squared. And then we got to plug in the force, and it said that you were applying a 250 pound or 250 Newton force. And then that squared is, well, we'll just write it in. I'll do it all on the calculator in a second. Okay? So that's the compression stress. And you can find that equation in your notes, but it's also in your textbook from pages 344 and 345 under stress and strain. In fact, it's the very first equation on page 344. So all these equations are on 344 and 345. Okay? Now that was part 1. So to get the answer for that, we just plug that in our calculator. I'm going to say 250. Whoops, you know what I need to do is I need to turn my calculator and put it in degree mode first, because I know it's not. And put it in degree mode. And then I'm going to say 250 times sine of 37 degrees. That gives me my top number. And I'm going to divide that by 0.04 squared. And I get 94,000. Right? Now another way that I could write that is I could say that the compression stress is 9.4 times 10 to the 4 using 2 significant figures. Now the reason I'm using 2 significant figures, I think, is because the way that it's worded in the textbook. Remember the rules for significant figures. If they give you figures, a certain number of significant figures in the textbook, that's what they want you to round it to. Okay, so it'd be approximately 9.4 times 10 to the 4th. And remember that for stress, the unit of measure is Newton meters squared. And we know that because this was newtons on the top here, and this was meters, and when you square it, you get meters squared. Okay. Now the next part of the question said, that was part A. Part B is, what is the shear stress of the bar? Now shear stress is a little different. That would be the cosine of the angle. Okay. So compression stress and shear stress are 2 different things. Compression stress, it depends on how you apply it to the bar. But compression stress, if it is 90 degrees, in other words, it's perpendicular to cross-sectional area, it compresses the bar, right? But this was kind of on an angle the way, so you're not the vector component that compresses the bar, that's the compression stress, okay? And so this right here is just the vector component that's kind of pushing into the bar, all right? Now, the shear stress is something that's a little different. Shear stress is kind of like a book, right? So shear stress, think of a book, but this would apply to the bar as well. If I take this book and I apply force to the top, it kind of transforms or deforms the book. It kind of puts it on a slant. And that can be calculated pretty similarly. Shear stress would be almost the exact same thing, except it would be f of cosine of 37 all over the area, right? And so you still have the force over the area because it's a stress, but the way that we calculate it would be differently. The reason that we have that cosine is because the picture looks different. It looks, because it's a book, your force is shoving the book over a little bit. Right? It's shoving the bar. It's transforming the bar a little bit. It's deforming the bar in a specific way. And so that angle phi, remember we talked about that? We said that the angle has a difference in it. So it's F over A over phi. Okay? And so what that looks like when we calculate that, we end up with this cosine of theta. And so we get 250 cosine of 37 all over 0.04 meters squared. And that's newtons, 250 newtons. And so it's the exact same thing, except we're going to say 250 times cosine of 37 degrees, which is a little bit different number, and then we're going to divide that by the 0.04 squared. And we get 1.2 times 10 to the 4th. So now that one, the shear stress is approximately 1.2 times 10 to the 4th. Now your textbook says 1.25. I don't know. Let me look at that. Was it 1.25? Yeah, you could round it to 1.25. I just rounded it to 1.2, but you could round it to 1.25. Okay? Any questions on that? Does that make sense?